Hello everyone, welcome to another video session of Mathematics Solution channel, and today I am going to explain how to find the solution of exact differential equation. So before going to solve problem, as usual, we'll discuss the definition of exact differential equation. And first we'll consider the first order differential equation. So that is in the form of m of x comma y plus n of x comma y into y dash is equal to 0. And we know already this y dash is a dy by dx. Just replace that. So m of x comma y plus n of x comma y into dy by dx is equal to 0. Now throw it operate by dx. So this equation will become m of x comma y into dx plus n of x comma y into dy equal to 0. Now just consider this is equation number 1, and this equation is called the exact differential equation if the differentiation is the m of x comma y into dx plus n of x comma y into dy is exact, and this is of the form which is which is the form du is equal to dou u by dou x into dx plus dou u by dou y into dy equal to 0. And just take this equation number 2 and is the function of u of x comma y equal to 0. And from the first equation, second equation, we can write du is equal to 0. And let us take this is equation number 3. And if you integrate this equation number 3, we can get it. If you integrate the number equation number 3, you will get u of x comma y is equal to c. And let us take equation number 4. Now we have first equation m of x comma y into dx plus n of x comma y into dy equal to 0, and second equation du is equal to 0, and compare these two equations. We can find the m value and n value from these two equations. So what is the m value? So m is equal to, here it is dou u by dou x, because m of x comma y into dx, here it is dou u by dou x into dx. So m is equal to dou u by dou x, and one more equation we have, that is n is equal to dou u by dou y. And now, so we need to verify the first equation is exact. From this above expression, we need to check the first equation is exact. For that, we can find the differentiate the first value m with respect to y and differentiate the second value with respect to x using the partial derivative. So this will become dou m by dou y is equal to dou square u by dou x and dou y, and the second expression differentiate partially with respect to x. So dou n by dou x is equal to dou square u by dou x and dou y. Now look at these two values, both are same. Dou m by dou y equal to dou n by dou x, which is equal to dou square u by dou x dou y. So that is, we can write it as dou m by dou y equal to dou n by dou x. Now the first equation is exact equation. Now already we know that this expression dou u by dou x into dx plus dou u by dou y into dy is equal to 0 is the function of u of x comma y. Now we need to find the u value. From these two values, we can find the u value. If we integrate this equation with respect to y, with respect to x, this equation with respect to y, we can get the u value. First, I will use this m value. Now we integrate. Let us take the equation number a and equation number b. From equation number a, we can integrate with respect to x. So this will become u is equal to integral m into dx plus some constant. I am using that constant, that is k of y. And similarly, from this equation u is equal to integral n into dy plus k of x. Now take any one equation, either the first equation or this second equation, differentiate partially with respect to y or differentiate partially with respect to x here. So I'll consider this equation. Let us take equation number 4, and this will become dou u by dou y is equal to m into dx. So this will become some value, that integral m dx into, we are doing with respect to y, this will become dk by dy, which is equal to, we know dou u by dou y is the n value, substitute n, and now substitute n value and we can find dk by dy is equal to some value. After taking integration we can find the k value. Substitute k value in the fourth equation, we'll get the u of x comma y. So this is the explanation of how to find the, or how to solve the exact differential equation. Thanks for watching this video. So in this exact differential equation, if you have any queries, please comment in the comments box. Thanks for the watch.